All right, this is what I really wanted to say. That last video I posted was review, but this I have not talked about yet. So this is in the document 1B. It is posted on the notes section of Classroom, but there it is. And this talks about how the width changes based on the confidence level and the sample size. And before we even talk about math, I want you to just mentally try and naturally think your way through it. If I take a larger sample size, isn't that going to cause it to narrow towards the value I'm trying to predict? And that does happen. As sample size increases, the confidence level narrows because it becomes more precise. If I have a bigger sample, wouldn't you think that naturally I have a better representation of what I'm trying to represent? So then it's easier, it narrows. But mathematically it works too, and I'll show you why. The confidence level, the percentage, as it increases, the interval widens. And my best example for that is if you're a data analyst working for a company and your boss comes in and says, hey, I want you to construct a confidence level based on this, based on such and such. And he's like, I do not want you to be wrong. I want you to be 99% confident in your construction. Because up there you see the specific formula. We're getting more specific. We're going to do the math of it next week. So he doesn't want you to be wrong. So naturally, let's widen the interval when we increase that confidence. I'm nervous. I'm gonna go out there on a limb and claim I'm 99% confident. Okay, let's widen it so that I'm not wrong. But mathematically, it makes sense too. So the critical value, we're only aware of z right now. So right now we're only aware of z. Pretty soon we're going to be talking about t, but it works just like z. So if I have a bell curve, then remember within one standard deviation I have 68%, and within two standard deviations I have roughly 95%. That's what we're talking about right there. We're going to reference that z-score right there when we are 95% confident. Sometimes we're going to be 90, sometimes we're going to be 99. And when we really construct it mathematically, we need to figure out what that number is. It happens to be 1.96 on the bell curve. We'll talk about that next week. Right now, you don't need to know that. Well, I guess we could use it. And then let's use it. Maybe it'll be a good reference. So right out here, we have maybe another threshold. It's not a specific standard deviation, but up to this point, it's 90%. And that number happens to be 1 point, oh, I'm out of room. I'm sorry, this is getting messy. 1.645. So let's write this nicer over here. For 95%, z equals 1.96, and for 90%, z equals 1.645. And then look at your formula up there at the very top. If I multiply by a larger number, this whole thing is my margin of error. And if that critical value z is 1.96 instead of 1.645, isn't the margin of error going to be larger? Naturally wider. So what I'm saying at the right here, as percent increases, the interval widens because I'm multiplying by a larger critical value. Sample size, if we look at proportions, this, by the way, is going to change again, but let's go off the one we know. it barely changes. But let's go off the one we know for right now. So we have these two memorized, hopefully from last chapter. But they are about to change on us. So look at those two formulas. If n increases, doesn't that mean I'm going to be dividing by a bigger number? That's going to shrink the standard deviation. And then look up at the margin of error up there, right up here. I'm going to be multiplying by a smaller number. So as n increases, it's going to shrink the margin of error, naturally narrowing the interval. So I'm going to clear this, pause it, and write down what you need. They have an opposite effect. As percent increases, the interval widens. As n increases, the interval narrows. Risk, I've rarely seen that come up. It comes up in our textbook, but I've rarely seen it come up in released problems. But just in case it does, this is associated with the confidence percent. So as this almost sounds like the opposite of what it would be. As percent increases, risk drops. So this is tricky. We have a multiple choice problem assigned, and it's tricky. When confidence, make sure I say this right, when confidence level stays constant, and I have one sample size versus another sample size, risk is the same. Risk does not change. When I go from a 95% confidence interval up to a 99% confidence interval, I'm now taking less risk by using a 99% confidence interval. And that's because of width, because the interval's widening. So as the interval widens, because of percentage, I have less risk. So then, if I take a 90% interval, if I take an 85% interval, I'm going higher and higher risk. It almost has an inverse relationship. Hope that makes sense. I'll take questions when I see you, or email me, whatever you need. I'll talk to y'all later. Stay warm. Bye.